Hi everybody, I'm Mike Strager from the Davis College of Agricultural and Natural Resources and Design. And first I'd like to thank Kurt for producing my document that I wrote last night that I didn't bring with me. So I'm glad I had this to talk about our activities in Davis College. So thanks for this invitation to present what we do up in the Davis College in terms of GIS and geospatial technologies. And, I'm kind of a strange person up there because I don't have one geography degree, but I'm kind of tasked in charge of integrating geospatial technologies with the specific tasks and things that our college needs for a lot of applied research uses and classwork for students' knowledge. So that creates a big challenge. And one of the things that's been really helpful has been the geography program here in terms of creating a structure, providing some classes, and also a lot of assistance with the tech center and so on with data sets to enable us to do things that we want to do or have to do in a Davis College, which is more of an applied GIS tool focus as compared to maybe more of the science, GIS science that is primarily taught and focused on here in the geography program. So I think the two work really well together because of that. The classes that we teach classes at both the undergraduate and graduate level, and specifically the undergraduate courses include a Foundations of Applied GIS course, and this presents GIS as a tool for problem solving. And we have two kind of unique follow-up classes to that. The two follow-up classes are focused on natural sciences, an introduction to GIS use in natural sciences, which is primarily our college, and also an introduction to GIS in the social sciences, which fits a lot of our rec and park majors, also our resource economics students, and some of our also agribusiness management students in our college as well. So that's the main undergraduate general courses. Some of the more specific undergraduate courses, we teach a remote sensing class specifically for foresters. And that class really originated back in the, early 90s, late 80s. With Charlie Yule teaching that, and basically it started only with photo interpretation properties and stereo pairs and measuring tree heights. It's progressed to using more LiDAR data for newer technologies and things like that. So that's a remote sensing course specifically for forestry majors. We also teach a summer GPS use and applications course. And there's two additional courses which have GIS technologies that are taught in recreation and parks, and also one in landscape architecture, which focuses more on the computer graphics and 3D visualization, which is very important for a lot of their landscape architect planning studies. At the graduate level, in our college, there's an advanced spatial analysis class, and the main area that we've expanded on recently has been in spatial statistics. We were able to hire a spatial econometrician, Donald Lacombe, who's added greatly to our program in spatial statistics and regression. And I've also, being a trained resource economist, economics is a science of trade-offs, I've been teaching a course in quantitative methods in spatial optimization, which pulls those things together for our graduate students as well. So those are the classes that we teach. We have centers associated with our college, the Natural Resource Analysis Center, as well as the Environmental Research Center, and the Appalachian Hardwood Center is also associated with our college. And the Community Design Team as well, which has a lot of overlap with needs for spatial data and analysis at a community and planning level. Besides those college centers, we also do a lot of work with the Water Research Institute and the Regional Research Institute. Those are two separate things, the Water Research Institute and the Regional Research Institute, as well as the Tech Center here. So some trends that I see in student education in GIS. Well, our trend in our college is primarily in these spatial technologies, in applied research applications, and really going across those disciplines. Second, we are seeing a lot of teaching that is occurring with geospatial technologies, not in these core courses that I mentioned, but additional courses and needs for workshops or kind of seminars in which different faculty that know these technologies come in and give maybe a week-long lab session or integrating with a particular topic that is covering something core to that particular class in which it's originally designed. The unemployment trends that we're experiencing, well, very important for our students, which are recreation, environmental protection, landscape architecture, entomology, soil science, wildlife, forestry. We've noticed that 7-10 years ago, if you had some geospatial technology experience, you were ahead of the curve. You did really well in terms of job search. Now it's to the point where employers are expecting that out of these particular majors. So it's very important that our students have these particular training and technology skills. So because of that, we've actually integrated these types of courses as requirements in the majors and not just electives. The accomplishments that our unit has seen in the past few years, we've seen obviously increased enrollment. Some of our classes started out with 15 to 20 students. Now we're up into 80s and 90s in terms of demand for them. And again, like I said, a lot of other classes in our college are offering special topics or components of the class that have geospatial technologies in it. What do I see as the most significant geospatial educational challenge that we are experiencing? Well, the most, I think, challenging part of what we do in terms of teaching a lot of these foundation courses is just what should be included in the foundations course. So we don't want to give them all this technology without having a good background in terms of the theoretical parts that are most important related to maybe projections, with topology, with dimensionality, with the importance of overlay, of different spatial analysis techniques, what you can do or can't do, with statistics when we have spatial data and so on. So that's a big challenge with us. One of the ways we overcome that is obviously encouraging all of our students as much as possible to take additional GIS science courses by the many talented faculty here in geography. And the last thing, what can the statewide geospatial community contribute to our ongoing efforts in our unit? Well, one of the things besides the internships, which is obviously very key, I think, is give us a lot of feedback. I like to hear from employers. What are you looking for in graduates? What have you had success with certain graduates? I see a bunch of graduates out there that have taken my courses that are doing well, and I like to hear that not only from them, but more importantly, probably from their bosses, right? So that's important. So any feedback related to their performance, what are you looking for additional characteristics or performance for students is always, I think, something good to know about. Okay, thanks.